In this video, we're going to take a look at naming some simple organic compounds. And it's going to be combining a little bit of Greek, a little bit of counting. It's going to be combining some skeletal structures and formulas and such. So it's kind of pulling a number of different things together. Now, to get started, we're going to make a table. This is going to be like a cheat sheet for naming our alkanes, naming our saturated hydrocarbons. So I'm going to start out here with our cheat sheet, and I'm going to have our formula. We're going to start out with our formula, and then we're going to have our IUPAC name. So IUPAC name, and then we're going to have what we would call then how it would be named if it's attached to something. So this would be the alkyl group name. Okay, so alkyl group name. All right, now we're going to start out with simple, small numbers of carbon atoms, and then we're going to build our way up. So we're going to start out with one carbon atom, and so one carbon atom would be CH4, and the IUPAC name for this would be methane. Methane. Okay, so this molecule right here is called methane. And alkyl group, what an alkyl group name means is if this methane is attached to something bigger, then we change the name of it a little bit. We just change the suffix on this. So it goes from being methane to methyl. It becomes methyl. And what does that look like? Okay, so we might say that there is a molecule. I'm just going to represent a molecule with like a squiggly line like this. And that molecule has this methane attached to it. And so we change the name to methyl. And instead of a CH4, remember this here is carbon with 4 hydrogens attached like this. We're going to take one of these hydrogens off and attach it. We're going to attach it to a larger molecule. And so here's a larger molecule. We're going to attach that carbon, and this becomes CH3. Okay, so a methyl group is CH3. A carbon with 4 hydrogens is methane. Okay, so then moving on here, we're going to have 2 carbon atoms, so C2H6, and this one here becomes methyl ethyl, so this becomes ethane, and the alkyl group becomes ethyl. So if there's 2 carbon atoms attached onto something, so if we have like a squiggly line like this, we would have CH2CH3 attached. Okay, so this would be an ethyl group attached to a larger molecule, or if it's just that molecule, it's ethane. And then we can continue right along. We can go C2H. Let's see here now, I might have to double check on this. C3H8, C3H8. This becomes propane. And this becomes propyl. And then we have C4H810. 10, and this becomes butane. butyl. And then C5H12, and this becomes pentane. And this becomes pentyl. And then C6H14 becomes hexane. And hexyl. C7H, can you guess? Because there would be, if we regular, that formula is, remember that CnH2n plus 2, right? So this should be H14 plus 2 would be 16, okay? I'm just trying to do that in my head. Okay, so 7 would be heptane. And then it would be heptyl. And then we have octane. So C8H, let's see, 16, 18. Right, 16, 18 would be octane. And then octyl. Okay. And then we have C9H20, and this becomes nomane. And this becomes nonal. And then lastly, we have decane. C10H22. Decane and DECYL, I believe. DECYL. Okay. All right. Now, unfortunately, we're just going to have to memorize these names. And some you might recognize, you know, octane, octopus, octagon is 8, decane, you know, so this is decade, or December, because December is the 10th month out of the year, right? No, it used to be, way back in the old days, December used to be the 10th month. But then there was this guy named Julius Caesar who decided he really wanted a month named after him. So then we ended up throwing in July, and he wanted it to be in the summer because it's nice. So he ended up with July. So then there's 11 months. And then his nephew becomes emperor, and his name's Augustus. And so you can see where this is going. So we end up with July and then August added. And then December now becomes the 12th month, just to kind of mess with our heads. And yeah, so anyway, 10 carbons is decane. All right, so you should take this table, make sure that you have this in your notes. You want to spend a little bit of time remembering these here, make some flashcards, because we're going to use this as like a cheat sheet for naming compounds coming up. So now that we have our cheat sheet with all of our names for like our basic building blocks or pieces of organic compounds, we can start putting them together to actually name some organic compounds. So I'm going to draw a couple of organic compounds first, and then we're going to go over the rules on how we would actually name this compound. So to get us started here, I'm going to take, let's see here, 1, 2, 3, 4, 5, 6. I'm going to go CH3, CH2, CH2, CH, CH3, CH3. Okay. And then we're going to draw another one just like it. We're going to go CH3, CH2, CH, CH3, CH2, CH3. Let's put one more on here. CH2, CH3. Okay, so here are our two organic compounds. And what we have here is we have like a backbone, and then we have these things attached. Okay, so here's a long molecule, and here's this thing that's attached. Now, these things that are attached like this, we call these substituents. So I'm just going to draw a little arrow, a little box around here, and we're going to call this a substituent. That is a substituent, T-U-E-N-T. Substituent. And really, I can spell. Actually, I can't. I'm terrible at spelling. All right. So this is the thing that's attached to this long carbon chain. And here we have a substituent. And the question is, which one is the substituent? Because really, there's 1, 2, 3, 4, 5 carbons. Or would this be the 5th carbon? And it doesn't really matter which one it is. Okay. But I'm just going to go like this one here. And I'm going to call this here my substituent. Now, these substituents, in this case, they are carbon atoms, but they could be chlorine, fluorine, bromine. They could actually be longer chains that are attached to it. But we're just going to try to keep things kind of simple for right now. All right, so two different molecules here. And rule number one. Rule number one is we want to figure out what is our longest carbon chain. What is our longest carbon chain in each of these molecules? Okay, taking a look at this top one here, longest carbon chain, it could be in a straight line, but it doesn't have to be. It could be bent. And so we could say that this one here is our substituent, like this. This here could become our substituent. Substituent. And our longest carbon chain for this, our rule number one, is find the longest carbon chain. So the longest carbon chain is 1, 2, 3, 4, 5. 5 carbon atoms. So we look at our cheat sheet, and we'd say then 5 carbon atoms. This is going to be pentane. So this will end up being blah, 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 something pentane. And this one here is going to be 1, 2, 3, 4, 5, 6 carbon atoms. And so this becomes 6 carbon atoms. It'll be blah, 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 hexane. Now, rule number two is we're going to number these carbon atoms in the longest chain. So like carbon atom 1, 2, 3, 4. And we want to number them so that this substituent has the lowest possible number. So for example, I could go carbon atom 1, 2, 3, okay? Or what if I went like this? If I started on the other side, I could go 1, 2, 3, 4, like that. Now, whichever way I number these, I want this substituent to have the smallest possible number. So I'm going to have to go back to the first way of doing that. So I'm going to go back here and I'm going to number these here. Okay, so I'll go carbon atom 1, 2, 3, all right? And then I'm going to do the same thing here. So I could start out here and go 1, 2, 3, 4, 5, but I want this substituent to have the lowest possible number here. So I'm going to go 1, 2. So it has a 2 there. Okay, so I'm going to number my carbon chain 5, 6, 1, 2, 3, 4, 5. I'm going to number my carbon chain so that my substituent has the lowest possible number. Okay, now my next rule is I want to name the substituent. Name the substituent. In this case here, our substituent here is a single carbon atom. This is a methyl group, and we want to show which carbon atom it is attached to. So we would say that this is 3-methyl. 3-methyl pentane. 3-methyl pentane. It's not methane because this single carbon atom is attached to a larger molecule. So it becomes 3-methyl pentane. And there's no dash here. There's no comma. It's just 3-methyl pentane. And we could do the same thing with this one here. We've got hexane, and we're coming off of the oh, wait a minute. I numbered that wrong, didn't I? This should be a 2. Better change that there to a 2. All right. You know, at the end of the day, I end up with fingers that are like all blue, and it's like, why are my fingers blue? I don't know. It might have something to do with the markers here. Okay. So 2-methyl pentane, and this one here now we've got 1, 2, 3. This is on the third carbon here. So this becomes 3-methyl 3-methyl hexane. 3-methyl hexane. And again, there's no comma or dash or anything like that right here. Well, then the question is, what happens if you have more than one thing attached to your carbon chain? All right, so let's take a look at that. I'm going to erase this here, like this. Let's go to CH2 here, CH2. One, two, three, four, five. This 2, and let's go like this. Let's put like this. Okay. All right, now for this one, we've got 2 substituents. We've got a methyl group here and a methyl group here. And so we would then want to name this. All right, so we've got the longest carbon chain is 1, 2, 3, 4, 5 carbon atoms. So we'll go 1, 2, 3, 4, 5 carbon atoms. And as it just turns out, it doesn't matter if we number it this way or if we go back this way. It doesn't matter because we're going to end up with our substituents on the 2nd and the 4th carbon atom, no matter which way we number this. Okay, now because we have 2 of these here, we're going to use a little bit of Greek. All right, but let's get started here. We're going to follow our rules up to this point. We need to identify our longest carbon chain. That's 5 carbons. And so this becomes something blah, 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 pentane. Pentane, like this. And then we are going to have 2 methyls on this, okay? So we're going to have to indicate where those methyl groups are. We've got it on the 2nd and the 4th carbon atom. So we're going to go 2, 4. So we're showing that these are on the 2nd carbon atom and the 4th carbon atom. And now we're going to use a little bit of Greek here. So we're going to say, because there's 2, we're going to go di for 2, methyl, pentane. So di meaning two. And if you had three on there, then that would be tri, like a tricycle. Okay, all right. So now we have two things attached. This becomes 2,4-dimethylpentane. Now what happens if these actually have different substituents? Now right now they're both methyl groups, but what if one was a methyl and one was an ethyl? How would we name that? Okay, so let's take a look at what that might look like. So in that case, I'm going to change this here. Change this here, change this here, change this here. And go like this here. And I'm going to put a 2 here. And I'm going to put a CH2 and then a CH3 like this. Oh, all right, now. This substituent here now is 2 carbon atoms, and this one is 1. And let's take a look at this. What does this look like? All right, well, rule number 1, we need to figure out what is our longest carbon chain. And we can go like more than one way. We could go 1, 2, 3, 4, 5. Or we could go 1, 2, 3, 4, 5. Same, all right, they're both the longest carbon chain. We could also go this way, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. All right. Either way, our longest carbon chain is 5 carbons, and so that's going to be 5 carbons is going to be pentane. Five carbon atoms is going to be pentane. And now we're going to have to number this, and we're going to have to name these substituents. So let's start out with naming these substituents. Naming these substituents, this one here, we've got a single carbon atom there, so this one is methyl. And then we've got 2 carbon atoms here, and so this becomes ethyl. And how do I know methyl and ethyl? That's going off of our cheat sheet, that we did earlier. Okay, so these are my 2 substituents, and so now I'm going to name these here. And as it turns out, when you name these, you do it in alphabetical order. So as we take a look at this, we see that E for ethyl comes before M for methyl. Now for numbering this, we could go in this direction or we could go in this direction. Now if we go left to right, our substituents are going to be on carbon atoms, let's see here, 1, 2, 3, 4, 5. So they will be on carbon atoms 3 and 4. Or if we go in the other direction, then they would be on carbon atoms 1, 2, 3. They'd be on 2 and 3. And so we want to have our substituents with the lowest possible number. So we're going to name this going from left to right. So this becomes 1, 2, 3, 4, 5, carbon atom 5. And we're going to say here now we've got a substituent on the second carbon atom and a substituent on the third carbon atom. So we're going to say 2 methyl, and then we're going to have a substituent on the third carbon atom. So that becomes 3 ethyl pentane. And we just put a little dash here like this. And so it becomes 2 methyl 3 ethyl pentane. And right here between this, there's no comma, there's no dash, there's no space. Now when naming organic compounds, sometimes we have some branched substituents. And these branched substituents have some special names to them. So for example, if I have a long chain of carbon atoms, such as CH3, like this, and then a branch coming off like that. Okay, so now we have some substituents that might be attached to this that have some branches of their own, which makes things a little bit funny looking. So for example, if I have 3 carbon atoms like this, carbon and then CH3 and a CH3, this has a fancy name. This one is called isopropyl. Isopropyl. There's another one called isobutyl. 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 And then there's also sec-butyl. And then lastly, tert-butyl. So these are all branched substituents that might be attached on like this. And so if we were to take any one of these and attach them onto our long carbon chain, how would we name that? So let's just take one of these here, for example, isopropyl. Okay, so we're going to take our isopropyl and we're going to attach it onto here. So we'll go CH and then the rest of the molecules, CH3 and CH3, like this. And so this right here is our branched substituent, okay? And that branched substituent is isopropyl, and it's coming off of the 1, 2, 3 carbon, 1, 2, 3 carbon like this. So then as we name this, this becomes 3 isopropyl and then our longest carbon chain, which is our base for this, is 1, 2, 3, 4, 5 carbons. 5 carbons is pentane.